Hi. Some of you might have seen my work outside recently. I hope you're not discouraged from, watching this till the end. It is a lot of fun, quadcopters, trust me, even if you have to rebuild them. So, yeah, they're always fun, huh? All right. So, hackers and quadcopters, just good friends. This is one of those well-prepared slide sets that has a lot of content which is completely random, but I'm trying to make it fun and relevant for you anyway. The point of this slide set is mostly to introduce you to the wonderful world of quadcopters, which is really wonderful, even though sometimes it's not so wonderful. So here we go. The point is that quadcopters are pretty much the perfect type of hackable object, or even an object that are created by hacks. And I'll point out why. The RC fanatics, the remote control fanatics that made all those planes and boats and all those types of things, they were already hackers in a lot of ways. I mean, there is no formal, make RC plane course at a university. There's no diploma that you can get to make things fly or do anything. So they're already on their own and doing all kinds of weird things to get something to fly, which is not supposed to be, made by normal people. So it's a lot of pure DIY. There is a lot of stuff out there that make it easier, but the real fun stuff is really the stuff that you make that doesn't have a kit available yet, that nobody did before, or nobody sells to you. So a lot of stuff is really, you need to be the first inventor of whatever you're going to make, because there's nobody who did it before you just the way that you are wanting to do. So thinking outside the box is a must. You must really think about, can I use something in a completely different way than I was supposed to be doing? And there are 100 ways to do things. All of them are wrong or all of them are right. It really depends on if you want engineering quality or not. And what do you get out of it if you get into quadcopter construction? Well, so there's a lot of physics involved. You get to know and understand a lot about thrust, power, all those types of things. There's a lot of electronics involved. You need to be up to par in, basic electronics, but also RC-related electronics, which is a world of its own. And there's a lot of programming now as well, because most of these things are really flying computers. I mean, a quadcopter will not fly unless there's a gyroscope on board. There you are. We were waiting for you, kinda. So, there's a lot of programming involved nowadays, or as much programming as you want. They're basically flying computers. A quadcopter cannot fly unless there's a very intelligent control system constantly updating its position with a gyroscope, an accelerometer. A lot of them have barometer, and of course GPS or whatever. There's Bluetooth connections involved, and all that requires a lot of programming to tie it all together. And of course there's the fourth thing, which is the most important thing with quadcopters: fun. There's a lot of gratification in actually having something that you put together from parts and then you get it to fly. It flies. I mean, it really flies. So, physics, I kind of bumped into a number of these things. I mean, it's all a combination of the amount of thrust that you can generate to get something off the ground, but of course every battery that you add adds more weight, so it becomes a kind of balance between more weight, battery, less thrust, blah, blah, blah. There's some math involved if you want, but you can also go for pre-cooked things and concentrate on just building something really weird out of a proven design. So you don't need to be a math head. Math head, I said it didn't right the first time. But it helps. It can be a lot of fun if you want to tweak algorithms and such. So electronics, you can keep it very low level. You can just say, okay, I bought some parts on the internet and I know how to solder, so I'll stick with soldering. Or you can actually go and make all the parts yourself. The flight controller has been made by people before. These things were hacks, and I'll come to that later. But you can buy a flight controller and add things to it, expand the I/O, add extra input outputs, and do all kinds of weird things that nobody thought of yet. There's a lot of fun things involved, like all kinds of different types of buses that you get to play with. If you don't know I2C or I2C, it is the best bus ever. It's a lot of fun. SPI is also fun, and all the other stuff. You will be introduced into a world of pain, I mean pleasure, and it will be a lot of fun to play around with this for the first time. So, programming. Basically, you could say that most quadcopters out there, there are a growing number of exceptions, but the first quadcopters out there were pretty much just flying Arduinos. The idea was you take an Arduino because people can use Arduinos, people understand how to program on Arduinos, and you don't need to worry about, you know, how do I get the microcontroller to do something and then write a program. No, you get a microcontroller that does something and you can directly program in it. So a lot of them are actually Arduino based. PID algorithms, believe it or not, they were designed somewhere in the 70s as a way to make a boat go straight in high waves with side wind. It's an algorithm that has three dots, which I miss. It's a proportional integral derivative. It makes a proportional adjustment to a certain error. So if your quadcopter is like this, and it should, or like this, and it should be like that, it doesn't turn all the propellers on at the maximum speed, but it proportionally adjusts it so that you get straight again. If you turn them on all this at the maximum amount of power, then of course you get flips or whatever weird things. So this algorithm is used in thermostats and all kinds of industrial controls, and it's actually also what keeps a quadcopter flying. So PID algorithms are a lot of fun to understand for the first time. Flight planning is a lot of fun. You can say these are waypoints that I want to visit. If you have a GPS on your quadcopter, you can make it follow these flight plans. Telemetry visualization. So telemetry is the name for if you have a link from your quadcopter down to the Earth. You can report all kinds of interesting information, like how much voltage do I still have left in my battery, how fast am I going, what is my heading, am I going south or west, or even if you have a GPS, it can report down where your quadcopter is, and you can keep a log or whatever. But there are also people that overlay it into video so that you actually get the type of video feed that allows you to see on a display where you're heading, what your altitude or your heading is. And all these things are actually mostly based on open source platforms and projects. So in any sense, this thing here is a hack. It's a flying hack. The motors there are motors that are not supposed to be used for this, but now are. It's a piece of wood in the middle. The aluminium beams have been taken from a towel rack. There's a popular brand in America that has very light aluminium, so everybody uses that. And in the middle you see an Arduino, I think, or a modified version, and I'll prove it. This is the Wiimote. Most people have seen a Wii, and there's a little module you can get for a Wii, for the Wiimote, which is called the Wii Motion Plus, and it has a more sensitive gyroscope than the original Wiimote has. So it's an upgrade. It makes it more sensitive, and it's supposed to be good when you're playing tennis on the Wii. However, you can hook that thing up. What you see down there is the PCB of the Wiimote or of the Wii Motion Plus. It has an I2C bus on it. You can connect it to the Arduino Nano, which is pictured above. And this is one of the first demonstrations of how you wire it up and how to. And then there's a description of how to put the software into the Arduino. Blah, blah, blah. And in the end, this is actually one of the first quadcopter designs that was out there. It was just a Wiimote, an Arduino, some motors, and a control. That's it. And this flew. And a lot of people actually flew with this configuration for a long time until the Chinese, God bless the Chinese, decided, hey, this is interesting. Why don't we just put these parts directly on a convenient board instead of putting it on a Wiimote that gets used by people to make quadcopters? Why not just make a quadcopter board? So the Chinese fully jumped into this market. And what you see here is a couple of these chips are a gyroscope, an accelerometer, a magnetometer. The one with the little dot in it is a microbarometer, so you know what the height is that you're flying at. There is a connection for GPS, and there's connection for in total 6 inputs and I don't know 6 outputs. So you can make a hexacopter, and this one at the bottom has a connection for a camera system. So you can have a camera that keeps level, all integrated in a board of less than 5 by 5 centimeters, and it costs less than 30 euros. So that's convenient, but they of course never stop making cool things, these Chinese people. So this one has the Atmega 2560 on it. So it's basically the Arduino Mega as they sell it, but then with everything that you want and more included on one board. This thing costs, I believe, 40 euros, which is cheaper than an Arduino Mega with all the parts separately. So you can actually make cool things with this, which have nothing to do with quadcopters nowadays. So this is completely hackable. Every part of this thing is completely documented. The software, this board can run at least 4 different types of firmwares. Everybody who ever jumped into quadcopters very deeply made their own version of firmware, because why not? You can. Yeah, it's great. This device here is what you saw in a couple of slides back. Oh, this was a bad idea maybe. Okay, so yes, this machine is slow. Yeah, I'll go back forwards and we'll skip. So this device here, on the there was a picture, you'll have to remember it. It was the one with the wooden plank and the 4 propellers. This one here is it's a speed controller, an electronic speed controller. In the picture, or the original picture that you saw, it was yellow, and every motor on every of the arms had one of them. And the electronic speed controller is a device which basically controls the speed of the motors based on an input that it gets from the flight controller. Now the interesting thing is, you would say that this is pretty much a store-bought, done, fixed piece of equipment, and you don't mess with speed controllers, because why would you? It just does what you want. Well, actually, people did. They took them apart and they found out, well, there's an Atmega 8 processor on there. There's a little bit of power control, and there's also a lot of FETs on the back. So field effect transistors, if you know them, they're very good for driving high currents. And people are using these devices now for CNC machines, because you can drive them and use them for all kinds of motor drives. And they are cheaper than any of the commercial drives that you can get, because this part costs 8 euros. You can flash a new firmware in there, and there's an insane amount of alternative firmwares available for all these types of speed controllers. There's one guy called Simon K, who makes the most the most well-supported firmware out there, that allows you to tune all kinds of cool things, and even makes it upgradable via the 3-wire connection. It creates a software serial emulation that allows you to program new firmwares without having to open it up and flash it with a normal flash tool. So that's really fun. Yeah, even that little part, a simple store-bought thing, has people hacking it and turning it into something else, and you can use them for all kinds of cool things. So what about extra things like camera jigs and other things you can connect to a quadcopter? So this is a 3D printed gimbal design, and it's called the Super Simple Gimbal, which, if you look at it, you could understand why. It's a keychain camera. So this is one of those very cheap Chinese cameras. It's the K808. It's super popular among people that fly planes and such, because they stick them on the plane and you're done. But of course, with a plane, you have less the problem that when you turn, the image turns completely weird. With a quadcopter, everything you do makes the image go sideways. So there's this guy who decided, well, you know, you can make a gimbal with just 2 little servos, a piece of tubing, and a little bit of extra firmware. Costs nothing. This is about, I believe, 8 euros of stuff. There's controllers that allow you to do the stabilization of the camera. So these are stabilization. The one on the left is the stabilization driver, which you can also use for normal handheld cameras. So there's people now reusing this type of work to make handheld camera systems that allow you to jump, run, etc., and still stabilize a camera. So that's a quadcopter camera controller now used for normal cameras. Really weird. There's a board called Minim OSD. You have it on yours. That's the on-screen display overlay system that allows you to superimpose all kinds of information about quadcopters, or about an aircraft, on video feed. So if you have a camera on your quadcopter, you can take that image that the camera produces, put it through this board. This board will put all kinds of information on top of that video feed and tell you you're now heading forwards, backwards, left, right. There's so much power still in your battery. This is your altitude, etc., etc. Really cool. And again, completely open firmware, completely open design. So even on the side of the transmitters, there's an insane amount of open source and hackable stuff out there. This is a commercial project. The original version was called the 9X, Turnigy 9X. Turnigy is a maker of a lot of these remote controls, and it was a very popular version. But the 9X wasn't so easy to use in certain ways. So a couple of guys opened it, made new firmware, said, hey, this is great. And then Turnigy said, oh, okay, well, we'll make the 9XR, which allows you to program it more easily because there's a header on the front that allows you to just flash new firmware in there. And then people said, well, this is great, but it could be more. I mean, now it's an Atmel-based thing with 60 megahertz. Why don't you make it an ARM version? So there was one guy who made an ARM replacement, the whole PCB inside. You could replace with an ARM-based version. Then Turnigy said, hey guy, why don't you go work for us? And now this guy is working for them. And there's an ARM-based machine in there of 80 megahertz. It can do all kinds of processing things on the transmitter. It's completely well documented, well supported. Firmware support is completely open source on GitHub, etc. No, Google code. And you can connect all kinds of weird things. There's people connecting external sensors on the transmitters so that you can have the Oculus Rift feedback to this thing, so that if you turn your head, the camera also automatically turns, etc., etc. And it's just a question of taking the right include file in the firmware files, adding your things to it, and making sure that it works. Settings, there's a lot of fun stuff to be done there as well. The configuration of the controllers is completely done in software, so no fucking around with a little bit of displays. Everything is USB connected or better, Bluetooth connected nowadays as well. Mission planning is available, so you can get all kinds of extra add-ons where you say, hey, please fly from X to Y to Z, and you can make it as weird and cool as possible. But there's a lot of more fun to be done. I mean, this is a 3D printed design, so it's completely made out of 3D printed parts. All the plastic parts are either 3D printed, and the black parts are completely laser cut, so you don't even have to buy anything. You don't even need screws. This is a design where you just need tie rips. So you use tie rips to tie everything together, and everything works that way. 0 screws needed. You don't even need plastic. You can make them out of chocolate. This is a chocolate copter. A woman made a version that is poured out of chocolate, and it flies as long as it's not too hot. You don't even have to have a flying quadcopter. You can make a floating quadcopter. This is the box copter. So this is a guy that decided to make everything inside the box. And you can store all the parts of the quadcopter inside the box, so you just throw it in the back of your car and drive around until you need it. You take the box open, you stick everything together, and then you can land on water. And this guy made it so that he can film whales somewhere in Washington State. There's a second camera on the bottom, and he films blue whales or something like that. Really cool. It doesn't even have to look like a quadcopter. I mean, the future is there. So this is a really cool design by a Russian guy who makes the most wonderful and weird objects based on existing quadcopter designs, but he just makes them look really, really cool. Then there are really, really novel things. So this is a quadcopter cut out of wood with a laser cutter. But if you look carefully, you will see that the rotors, the propellers, they're a little bit different than normal. So this is a variable pitch quadcopter. What it means is that just like modern helicopters, a normal helicopter has a rotor that can tilt its pitch so that you can decide if you want more or less lift without actually turning the motor faster or slower. So you spin up the motor, it has zero pitch, so it doesn't go up or down, and then you slowly tilt the blade so that you have more lift and slowly go up. This thing has that as well, so all the motors always are at a single speed. But funnily enough, you can also tilt the blades the other way, and then you can fly upside down. So you can do insane stunts with this type of thing. There are people that are able to control these things so wonderfully well. It's very, very scary. You don't even need to buy parts because a lot of the stuff that is out there can be made yourself. This is one of the first projects around quadcopters. These motors that you saw on the previous one, those motors are called outrunners, and they're based on a design which has been used for ages. This is a CD-ROM motor. Before CD-ROMs, these motors were being used in floppy drives, and before that probably in some device, I don't even know. And these motors you can rewire or redesign a little bit, and then you can actually use them on RC models like this. So there is actually a group of people who make ghetto copters, which just use parts that you found in some garbage bin, and you rewire it and make it fly. So it is all that and probably more. There's a lot of stuff to be play around with. It's very varied because it's not just one type of terrain you're covering. It's not just electronics. It's not just physics. It's not just programming. It's a lot of everything. And currently the field is still open. That means that there are commercial offerings out there. There are some really good ones, some really expensive ones, and some really doable ones for hobby use as well. But it is still possible to get something made yourself which performs super without spending too much time or money or anything, and that's really, we're still at the forefront of quadcopter design in that sense. Regulations for hobby is still open. That means that for hobby use, at least in most countries, under 25 kilos, you're still allowed to fly anything. And in a large area of the country, as long as it's not on the airport, you wouldn't have too many problems. So yeah, that makes it fun. Oh yeah, and it's fun. I told you that. Did I say it's fun? It's fun. So this is a photo opportunity. This is if you like to know, or if you like to have a couple of URLs that can be really, really handy in getting your stuff together. These are a couple of places to go and look. The bottom one is the creation page of my X project right there, which will rise again, I am sure. It's only a little bit broken. It is just resting. So yeah, there's a lot of information on the bottom one. I have the design files there. So it lists all the stuff that went into this one, and it also lists the URL of a workshop I made, which is about 3 hours long and has 137 slides, which is available as a PDF there, and you can sort through the information, and it lists insane amount of information. So yeah, might be handy for you. So in conclusion, quadcopters are flying hacks. I mean, really, there's nothing regular about these things. They can't fly without a lot of compute power, a lot of ingenuity, and a lot of other stuff. You can make them do all kinds of weird things, and quadcopters should be hacked to do more things. And hackers, in my opinion, should be quadcoptered more, simply because you get to get so much experience in so many different fields with one project like this, that I encourage anybody, everyone, all of you, to build quadcopters and make sure that you have a quadcopter or two to show at the next Balcon. Thank you very much. Are there any questions? Yeah, you first.
Okay, thank you. I would like to ask you, what is the
Well, that's an interesting question because the Chinese somehow managed to do it with in a budget that isn't even possible if you start doing it yourself. I mean, I've now seen an $18 quadcopter, including the transmitter. I mean, how the fuck do you do that? How the hell do you do that? But it's also going to be very, very small and very, very light and not very fun to fly, maybe. So this one, back when I started building it, was around 120 euros. And I think nowadays the parts are even cheaper. If you make some of these things yourself or take some tough design decisions, like, oh, you know, I'll not buy a speed controller with 30 amps, but just 15 amps because I only need 12, maybe. You can shave off a couple of euros. To be honest, you will break stuff. I mean, this thing is not natural. It is a brick with propellers. I mean, there's nothing natural about this, and a brick is not supposed to fly, but it does because it doesn't know this. So you will break stuff. You will break propellers. You will break an arm of the quadcopter. You'll break a motor maybe, and in the end, probably it will cost you around 150 for the first year of flying. That's realistic budget, I think. It can be in the price for 150, yeah. If you get 39 US dollars is the lowest price I've seen for a 6-channel transmitter at 2.4 gigahertz. It won't have many options, but it will serve you well for the first couple of years. But if you want to go fancy, you can go all the way to a couple of thousand euros. But I think the lowest budget, realistically, think of 100 euros. Then you'll have your first model, it will fly. It's doable. Yeah. Yeah. Well, so there was this time that it fell out of the air onto a car. Let's see. Yeah? No. Yeah, I thought so. Well, that was one. I don't know. We fly a lot in the park. A lot of people have insane comments about a flying thing. Some want to, you know, scare it away. Some let the dog chase it. I don't know. It's weird. Sometimes you have to get it out of a tree. I don't know. There's a lot of weird things that happen with things that fly. In Holland, don't fly it around military objects. If you see a military object, do not fly there. I think that's safe to say. Anybody else?
Can you try to make an alien come out of it and scare the shit out of people?
Well, not yet, but there is another guy who is building a large LED sphere, which he's going to put underneath a quadcopter. It has 900 LEDs, RGB, and it weighs about 1 kilo without the battery. And he wants to make a portable sun, so that in the middle of the night you can fly somewhere and then have the sun come up. That's his goal in life.
So for the next version, there will be lasers.
Oh yeah, that's one of my hopes. So I'm hoping to modify this one, or I'm hoping to make a quadcopter one day that will have a couple of little mirrors on the propeller rotors. If you know how the laser drum works in a laser copier or a laser printer, there's basically a 6-sided or 8-sided nut, which is highly polished and acts as a mirror. And what you can do is you can aim a laser at it, and once you do, it will turn into a horizontal scanning line. It's also how a lot of these laser shows work. So if you put 4 lasers on a quadcopter and you have 4 really fast rotating mirrors on top of it, you should have an interesting light show flying above you. So that's one of the things I'd like to do. Yeah. So. Anybody else? Any questions about squirrels? No? All right. They are extremely dangerous. If you see an armed squirrel, run. So, all right, thank you very much.